welcome to True Projects. In this video, we are going to explain about the project which is nature-inspired optimization in context-aware based coronary artery disease prediction, a novel hybrid Harris-Hawkes approach. Before getting into the execution, first let's understand what is the project about. So, what is this coronary artery disease? It is disease related to heart where it is caused by narrowed arteries that restrict blood flow to the heart. So, when people are affected with the disease, they don't receive the blood flow due to the narrowed arteries where it causes a person death. And it is a major cause in the global wide. So, it is early and accurate prediction. Early and accurate prediction is essential to mitigate health risks associated with this particular disease. So, here where machine learning comes into the picture. So, machine learning it provides powerful means of predicting CAD by analyzing patient data such as age, cholesterol levels, and also the blood pressure. However, challenges arise when working with the high dimensional data sets, which contain numerous features. For example, while analyzing a patient's medical history and lifestyle choices, not all the variables are equally important. Some may add noise rather than the value. So, therefore, effective feature selection is crucial. By identifying and focusing on the most relevant features like just blood pressure and cholesterol, we can enhance the accuracy and efficiency of the machine learning models, ultimately improving the CAD prediction and patient care. Moving on to the nature inspired algorithms like Harris Hawkes optimization techniques, these can significantly enhance the machine learning models, but they have downside that they can get trapped in the local optima. So this means they might settle for a solution that isn't the best, which can limit the accuracy when predicting complex disease like CAD. And additionally, medical data sets they face the issue of class imbalance. So they often suffer from the class imbalance where there are many more negative cases than the positive ones. For example, in a data set with CAD predictions, there might be only few patients with the disease compared to those without. So this imbalance can lead models to favor the majority class that is patients without the disease, making it harder to identify the actual CAD cases. Addressing these issues is essential for improving the accuracy of CAD predictions. Moving on to address all these issues in this project, hybrid Harris Hawkes optimization approaches proposed to improve the prediction of coronary artery disease. Essentially, this method focuses on optimizing the hyperparameters of the well-known algorithms that are support vector machine, logistic regression, k nearest neighbor, and random forest. What this means is that instead of just using these algorithms as they are, we fine tune their settings to get the best performance possible. For instance, each algorithm has certain parameters that can be adjusted, such as complexity of the model, that is how it learns from the data. So, by optimizing these parameters using the HHHO approach, we can significantly enhance the accuracy of our predictions for CAD, making it more effective tool for early diagnosis and patient care. So here we also use context aware model to identify the important features needed for prediction. So this makes analysis more focused. When we tested this approach on UCI heart disease data set, the HHO method outperforms than the traditional HHO. So the hybrid HHO model, it outperforms the HHO model. So this shows that the hybrid HHO is effective than the CAD prediction and suggests that it could be also applied to other medical data sets, thus potentially improving the healthcare outcomes overall. Moving on, as the extension of the project, we have decided to implement an ensemble model. So in this project, we have implemented an ensemble method. So here we have combined, all the ensemble methods, they combine multiple predictions from multiple models to create a final prediction that's both more accurate and reliable. So one technique where we are looking is, in this project, we have implemented voting classifier, which is ensemble model. And here we have combined bagging classifier with random forest and decision tree. And also as the extension, we have built the front end using Flask framework. This will allow users to interact with the CAD prediction tool easily, and this will include user authentication to ensure secure access. Overall, this extension is aimed at improving prediction accuracy while making it more user friendly. So to implement this project, we have followed these steps. So let's know what are these steps are. So first we have imported all the necessary packages and then we have explored the data set. After exploration, we also did some pre-processing where we have dropped unwanted columns and we clean the data set. Then we visualize the data set. After visualization, we convert numerical data, categorical data into numerical using this label encoding technique. And then we append all the features to X variable and target to Y variable. And from that data, we select important features using the existing HHO feature selection technique and the proposed hybrid HHO feature selection technique. After selecting the features, we split the data into train and test sets. Train is for training the models and test is for evaluating the models. After train and test split, then we build the model, train the model, and then we compare all the models with the error metrics that are accuracy, precision, recall, and FN score. And we compare all the models using graph. And we developed frontend using Flask framework along with the registration and login setup with support of SQLite database. After setting up the front end, then users they'll be able to log in, they'll be able to give the input feature values, and those feature values they will be pre-processed at the back end, and that data will be the given input will be fitted with the train model for the prediction purpose, and then we get the final outcome. So this is all about the theoretical concept. So coming to the algorithms used, we have used random forest, support vector machine, decision tree, logistic regression, and the extension model, voting classifier. So among all the models, extension model, that is voting classifier, has performed well with the HH, that is hybrid HHO technique. So we have deployed it in the front end. Coming to the requirements, to implement this project, we need some basic requirements, which are hardware and software. So coming to hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies of HTML, CSS, JavaScript, and Bootstrap 4. Now let's execute. To execute, we need to open the code folder which contains source code files. So these are the source code files in the code folder of the project. Now let's understand each of them. How will they be used in the project? So in this archive folder, we have the dataset used in the project. That is the heart disease prediction dataset. So let's open it. So this is the dataset used in the project. And here, all are the independent features which impact the heart disease. So using this, we'll be predicting the heart disease. And this is the target column which we'll be using for prediction. So this will be predicted using all these independent features. So here we have two classes. One is presence and the other one is absence. Presence means heart disease is present and absence means there is no heart disease for the person. Let's close this, get back. So this is the models folder in which we have the algorithm information. This will be loaded into the project code during runtime of the project. And this is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal of the project. And this is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this is app.py file. This .py file contains the information related to front-end logic of the project. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. And these two are the notebook files which contain the code. This is Jupyter Notebook file which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, which makes it a popular choice for the data science. And here, this is the signup.db file. This is the database file which is used to store the user information. And here in the sample file, we have the test cases. So let's open it. So these are the test cases we'll be using in the front end to detect the heart disease. Now close this. Let's execute. So to execute, copy the path of the code folder from the address bar of the file explorer. I'm copying the path. Now open the Anaconda prompt using the command cd followed by the space, paste the copied path and now click on enter. Here if you observe, current directory is changed to the code folder's path. Now we have to compile the app.py file. So give the command python space app.py and click on enter. So this command, it will execute Python script and check for all the runtime errors. It will it will perform the runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the localhost and the port. So this is the localhost and the port, unless configured differently. So now we have to copy this local link provided by the Flask framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I will paste it in that. Paste the link here. Now click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So let's sign up first. Click on sign up and enter all the registration details if you are registering newly. I have already registered, so I'll directly sign in. Click on sign in. Give your username and the password. So I'm giving my username and the password. Click on sign in. I've signed in successfully and I'm redirected to prediction page. So if you observe, I'm redirected to prediction page. So these are the parameters which are need to be given. So based on the given input, we'll be getting the prediction. So let's understand them first and then give the inputs. So first parameter we have is CP. So CP, it refers to the type of chest pain the patient is experiencing. It is typically categorized into different types, such as typical angina, atypical angina, non-anginal pain, and asymptomatic. Each type provides important clues about the heart condition. So the next one we have is heart, that is FBS, that is fasting blood sugar. This measures the blood sugar level after fasting for a certain period, typically 8 hours. It helps to assess whether a person has diabetes or is at the risk for it. A higher fasting blood sugar level can indicate an increased risk of heart disease. Coming to exang, so exang, it is exercise induced angina. This refers to whether a patient experiences chest pain or discomfort during physical activity. It is crucial indicator because angina can signify that heart is not getting enough blood, which is a risk factor for coronary artery disease. So coming to slope of ST, it is the ST segment slope. So this is part of electrocardiogram reading that shows the heart's electrical activity. It is a slope. The slope can indicate how heart responds to the stress. A downward slope might suggest issues with blood flow, while a flat or upward slope is generally more favorable. The last one we have is number of vessels fluoro, that is number of major vessels colored by fluoroscopy. This input counts the number of major blood vessels in the heart that show blockages during a fluoroscopy procedure. More blocked vessels can indicate a high risk of severe coronary artery disease. So now let's give all these parameters, I mean, give inputs to these parameters. So those we have in the sample folder. So let's open the sample file. So let's give all these parameters. So let's try with the second test case where CP is 2, FBS is 134, that is fasting blood sugar level is. Exam value is 0, slope of ST is 162, number of vessels fluoro is 0. Now click on predict. So here we got the prediction that negative, which means patient is not suffering from any other heart disease. Let's try with the other test case. Let's try with this test case. Click on menu, click on prediction. So here the CP would be 3, FBS is 122, exang is 0, slope of ST is 165, number of vessels fluoro is 0. Now click on predict. So this given input will be pre-processed and trained with the model, and then we'll be getting the prediction that here we got the prediction that negative, which means patient is not suffering from any other heart disease. Let's try with the 11th test case. Click on menu, click on prediction. CP would be 4, FBS is 132, exang is 2, slope of ST is 105, number of vessels fluoro is 1. Click on predict. Here, based on the given input, we got the prediction that positive, which means patient is suffering from the heart disease. So now let's try with this 16th test case. Menu, prediction. CP would be 4, FBS is 110, exang is 2, slope of SST is 114, and the number of vessels fluoro is 0. Click on predict. So here we got the prediction that positive, I mean patient has report positive. That means patient is suffering from the heart disease. In this way, by just giving the input features, we'll be getting the predictions based on the given model. So now let's click on graph. So here we have graphs of both the notebook files. Coming to original, here we have graphs related to features extracted from the data using proposed hybrid HHO and the models built on the feature selected from that model. And here we have context aware based model. So first let's check with the original one. Click on that. So this is the sample outcome graph. This shows the distribution of each class. So here on x-axis we have absence of the heart disease and presence of the heart disease. And on y-axis we have the count of each class. If you observe, presence is less than the absence. And here we have existing HHO feature selection technique where on x-axis we have accuracy and on y-axis we have algorithm name. And here we have precision score, recall, and F1. And here we have the proposed HHO technique, that is hybrid HHO feature selection technique. Here also on x-axis we have accuracy score and on y-axis we have the algorithm names. If you observe voting classifier, the extension model is having the highest accuracy. And this is the precision score, recall, and F1 score. Now let's check with the CAM. So here we have same sample outcome graph and here we have accuracy graph, precision, recall, and F1 score. Now click on sign out. In this way, by using the feature selection technique, that is hybrid HHO, and the extension model voting classifier, efficiently we were able to predict the heart disease. So this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.